Yeah, all right. So we'll record this. Wide area networks. So when we're talking about wide area networks, we're talking about using a third party, somebody else besides ourselves to provide a lot of that network connection. So it's over big distances as well. So that's like we'd use Ooredoo to connect one office here in Doha to somewhere else in Qatar, or maybe even somewhere else around the world. So we're actually using a third party which has those that infrastructure ready, and they're going to do that for us, typically on a rental by the month basis. But it could be, I mean, if it was something where that telecommunications company operated over the entire geographical area of our network, we might be able to get them to put in some special infrastructure for us. But typically we just rent it by the month. So these are the things we're going to talk about. Identify fundamental elements of WAN. What are the options? Compare and contrast WAN technologies at layer 1. So we're going to look at layer 1 and layer 2. So layer 1 is the physical stuff, right? Are we using copper? Are we using fiber? And how is that implemented with the other devices in there? With the layer 2, we're going to be looking. So layer 2, is your frames, etc. So are there different things that we can do with those? And we do have a few different things we talk about at the end of this lecture. Using frame relay, etc. ATM, asynchronous transmission. Explain the most common wireless WAN technologies. Maybe we'll get to that again. That's at the end. So talking about using microwave towers and satellite, etc. All right. So WAN, wide area networks. It's always going to be over some distance. It's always going to involve some other carrier besides ourselves. Depending on how much money we have to spend, depending on how much traffic we're going to use, our bandwidth requirements, that will, depending on how far away our different offices are, etc. Depending on what technology is available at what price, that will affect the decisions we make on how we're going to do the WAN. So there's more than one way of doing WAN, obviously. If you go to Ooredoo and say, I want to connect to, offices, there's many different options that you could come up with. And a lot of the technology you might just use yourself, right? Some kind of VPN stuff. So basically, you should know the difference between these terms, LAN and WAN. I think you do, right? So your local area network versus your wide area network. Your LAN technology, that's on you. You take care of it. That's all yours. Oh, you could pay somebody to do that, but it's still you. But our WAN technology, that's going to be our service provider, Ooredoo, is going to sort of take care of that for us. But we'll pay them. Layer 1 and layer 2, as I mentioned. Layer 1, we're just looking at the physical bits of it, and layer 2, we look into the frames. WANs are typically owned by telcos. In our case, that would be not AT&T, Verizon, Charter, or Comcast, because they're American. In our case, it would be Ooredoo or Vodafone would be taking care of the WAN sort of situation. On the left, we've got a LAN. On the right, we've got a WAN. I hope what you're supposed to see there is a difference in scale. The WAN is, the sites are much further apart. And yeah, there may be many of them. We do talk about this idea of a point-to-point. So at each of these WAN of these sites here, we have a point-to-point connection to the other sites. So what's this one about? Data terminal equipment. So we have two different things there that we talk about, DTE and DCE. So the DTE, data terminal equipment, you can see it over here sitting in the yellow stuff, which is actually owned by and controlled by the individual user. That's their stuff. That's on them. They take care of that. The green stuff is supposed to represent the telecom carrier. And the telecom carrier is going to have some equipment there, which we'll refer to as DCE, which is our data communications equipment. That's not owned by us. If this was our network, right, that would be owned by Ooredoo. But we would own this stuff in that we call the DTE. Khadija? Yeah, so the DCE, as it says there, refers to the endpoint. In the previous slide, you saw what we called a point-to-point connection. Point-to-point connections are from those endpoints. And so that would be talking about all this stuff out here that the telephone company is taking care of. And yeah, so that's the WAN connection that we're talking about there. So we can have different ways of going about this. We could have a cable that we actually kind of like rent fully. That's ours from the telephone company. We'd call that a dedicated cable. That would, as I said earlier, that would be if the telephone company sort of had that kind of control over that geographical area. You know, so we could have a cable from here to Cannes that nobody else could use. You know, if we were really worried about security and didn't mind paying the extra, yeah, maybe that's a good idea. Virtual circuits, on the other hand, we just sort of, we're putting our traffic onto the carrier's network, and we don't have any physical part of that which is set aside for us, but just using the protocols that they have, they can sort of make a virtual circuit as required. And so that's going to be a lot more flexible. And the new technologies, when I say new technologies, basically in the last 40 years, you know, so with digital networks, et cetera, that there's a lot more flexibility. And so virtual circuits seem to sort of work. Now, virtual circuits have different categories. We can have what we call a permanent virtual circuit. So before we actually do any transmitting, there's a sort of a connection set up, or we could have switched virtual circuit. Switching determines how connections are created between the nodes. And so we talk about packet switched and circuit switched. So circuit switched would be the idea that it's kind of like a telephone call, that when you start the connection over that line, everything that's happening is your communication, as opposed to the packet switched. I think that's, yeah, the packet switch, your communication is broken up into packets. That's how the internet works anyways, right? It's all packets. But you can do that over the telephone communication networks. And that's obviously a lot more flexible. And yeah. So here we have some of the different ones. As we're going down here, we're getting to the more modern, bigger, more expensive sort of solutions. All right, so our simplest solution, dial up over the publicly switched telephone network with a point-to-point connection, PPP, on copper. Nowadays, okay, to be fair, nowadays we've got fiber going into people's houses. And so we wouldn't really be doing, in Qatar, we wouldn't be doing that. So dial up an ISDN, that's for old people like me to look at and think about and say, oh yeah, back in the day. You're probably not going to come up against it too much here in Qatar. Digital subscriber line, that's a little bit different. And notice that it's, so actually here, point to point, for ISDN, we're getting into frame relay already, frame relay, ATM, these types of things, we're using some kind of flexibility with the protocols in the frames. And so that's using layer 2, not just layer 1 connectivity. Cable broadband, we used to have coming into people's houses a cable, which would be like a coax cable that was bringing something maybe from a satellite down the road or even on a roof. And or could have just been there with the telephone company connection coming into our house. That's kind of not too much nowadays, I guess. Should have my Metro Ethernet. Now, what's happening with the Metro Ethernet that might be interesting is the MPLS, so multiple protocols. That means that they have all kinds of flexibility. They can use whatever protocols of WAN technology they like. Now, when I say whatever protocols, we've got our ISDN protocol, we've got our DSL protocols, ATM protocols, frame relay protocols, or they could just go and sort of switch over copper using old style. So that really gives them a lot of flexibility in the way that they provide that connection. That's very nice for them. T-carriers is a way of bundling up a bit of bandwidth over the public network and sort of selling it at a monthly rate. And so you're not actually giving them anything physical. So a lot of this stuff is not physical, but you'll just say, okay, between this point and this point, we're going to give you a T1 connection. And all they do is they guarantee you a certain bandwidth at a certain price for a certain time. So there's T1 and then there's T3, etc. Yeah, and so they're going. So that's why we're using multiple ways of doing it, right? We could use frame relay or ATM, depending on what is the actual infrastructure that company has. Last one there, SONET. SONET is really relying on fiber in the backbone of the telephone company, but again, it's using multiple different protocols available to it. Now it's called. We got a slide on it later on, but SONET is what they call it in the United States. SONET and Canada. It's not a word that's used broadly internationally in Europe or Asia. So if you're looking to find SONET in your Asian country, it would probably not be called SONET. There's another name. I think it's SDF or something like that. The same kind of idea, but they only use that name in the United States and Canada. So when I say Asia, I mean all of this area, but I'd also mean Australia, New Zealand, probably Africa too. All right, so the idea here is supposing you're having problem with your WAN connection, maybe before you go and talk to Ooredoo or Vodafone or whoever you're sort of contracted to give you a WAN connection, maybe you should look at some things at your end of the thing, right? At your DTE end of things. So maybe you haven't sort of configured it properly, there's some suggestions there. Maybe there's some things that you could do about that. Really sort of tend to your own customer premises equipment before you start talking to the ISP. Okay, that's going to save you some money maybe, but also maybe it's going to save you some time and stuff because they can't actually solve your problems on your work site, right? That's your stuff. And so you need to sort of look there. And I guess that's what you guys are aspiring to when you graduate from your course here, is that's the type of problems that you'll actually end up sort of dealing with, right? So what's happening with our routers, what's happening with our equipment that connects to the internet on our side, the DTE. So there's a lot of work for individual people there to do that before they sort of start talking to the ISP, the internet service provider, or as we say, our telephone company WAN provider. So as a customer with your own little network, you've got some devices that you need to take care of, and one of them is this, your network interface unit. Now one of these is referred to as a smart jack. Smart jack sort of shows up a bit later when we talk about our point-to-point connectors. Line driver is just a line driver is increases the how do I say, the intensity. It's like an amplifier, amplifies the signal. So coming out from you. So any of these things could go wrong, and you need to look at it. Your CSE, your DSU, usually that's just going to be a box that we refer to as like a modem. So that's going to be that. And so, you may have errors on your interface. You may have errors with your DNS. So that's going to be an internet issue, right? Your routers might not be configured properly, and those are things that are all on you. There may be some interference. We talked, that's like from the first lesson. So physical layer, all of these things, have physical layer aspects to them. So I mentioned to you that SONET is using fiber. Your T-carrier connects, could be ISDN and DSL. Your telephone company is going to provide you with a specific connection at the layer 1. With broadband, that is an interesting point that we're actually sharing our broadband with other customers. And that's the flexibility, and that actually keeps the price down, right? The fact that that broadband is not dedicated to us at all, but we have a certain amount that we sort of pay for a certain availability. So that's why I think this is right. Ooredoo rings me up like once a month. This is your, you have this equipment in there, you got this much bandwidth that you're paying for. Would you like to upgrade it? All right. So I'll say, yeah. And so they charge me an extra 50 or 100 or 200 reals a month. But that they don't have to come, they don't have to send a technician around, right? All they have to do is, a few changes in the configuration, because all of the hardware and the connection's already there. All they have to do is change the configuration a bit And so this is the broadband that we're talking about here, is how much of that share are you going to have? I'm sharing that with other people in the building, et cetera. And so now I paid a little bit more, so my share becomes a bit more. That kind of thing. So we've got asynchronous or asymmetrical bandwidth. That's going to be a little bit cheaper than your symmetrical, but the idea there is that, as you see, our download speeds are going to be faster than our upload. If you're just using your bandwidth to watch Netflix, that's probably what you'd want, right? I mean, you know, how much upload are you doing, right? And unless you're sort of producing a lot of content for Netflix, but you probably aren't. Dedicated internet that's going to be a little different, right? So that's going to be symmetrical. You could get a dedicated internet access, and so that's if you wanted to upload a lot of stuff over the network. So your speeds would be the same. For most of us, we're just going to go for the asynchronous, asymmetrical. But if you're a business and you've got to back up a lot of stuff, you might want a dedicated. Definitely if you're a bank or something like that. I mean, yeah, you're going to have your own sort of thing. You don't want to be sharing that with other people. And you got security issues there too, also, if you're a bank, I suppose. Public switch telephone network. We also call it POTS, P-O-T-S, plain old telephone system. Circuit switching. The idea of circuit switching is I pick up the telephone. That's a public switch telephone network. And I dial a number and I ring somebody. During the time that we're talking, we have a virtual circuit through there, right? We're switched. So that's, now imagine if all of your WAN was like that. You dial the number and yeah, so the problem is that sounds nice, but you're paying, the way the telephone company works with that is they charge you by the minute, right? So it's good that you don't pay if you don't make any calls, right? So as long as the phone isn't, as long as you're not calling, you're not paying for that. But as soon as, every time you make a call, you're paying by the minute. So you probably don't want to use that as your way of getting a WAN if you've got a lot of traffic, right? So it might be better to have some kind of monthly setup that just looks at the traffic, etc. Now the idea of analog, you guys know the difference between analog and digital, right? So an analog signal, like my talking to you at the moment, that's analog. But what you hear, how that works between coming out of my mouth and hitting your eardrum, you know, there's a vibration, and then there's a nerve that fires. All of that's analog. But so digital is if you took that signal, which is compressed airwaves, and you turned it into a square wave, then it would be a digital. Digital is important if you're going to use computers, because computers aren't real good with analog. They can sort of, they can emulate it, but they're really good with analog. Sorry, with digital. They're good with square waves, because square waves represent a 0 and a 1. And you can just do a lot of things with those. But so long story short, all of our computer and telephone networks nowadays are no longer analog. And that's because the telephone exchanges, our routers, our switches, etc., that's all sort of works in the digital world. Our telephone exchanges, that 80s, 90s, from analog to the digital. And so, yeah, used to be analog. It's not anymore. So we have this concept of a central office. The central office is not ours. That's part of the telephone company. All right. And so basically the central office is a point to which we connect to get our WAN connection. Right. So we connect from our office to the central office. And so where as it says there, where the telephone company terminates its lines with us, we connect to that. And yeah, switches between different connections. The local loop, or the last mile, we used to call it the last mile. This is a big problem the telephone companies are working through in the 1990s and the early 2000s, because the first thing that telephone companies did is they built up their trunk lines. They put a lot of fiber in there. And then they'd get to the central office, which we talk about, right? So the central office might be this sort of telephone exchange in your area. And then from there, it was copper wires that went out to people's houses. And, you know, that was a limiting factor. And so the problem was the last mile. How are we going to get people to have the broadband experience that they want when we got this copper running out to their houses? So we come up with a lot of sort of different protocols that we use to make things faster. But in the end, the engineers knew that they really had to have a faster physical connection. And so that was fiber, very expensive. Telephone companies went to a huge expense to sort of get that last mile out there. It was kind of like, yeah, basically putting fiber into people's houses, so way more expensive than the trunk upgrades. And so that was a big challenge. Not every country has been able to do that, but certainly it is in Qatar. So we got fiber in everybody's house. So that last mile problem has been solved. And when I say not every country has been able to do it, in countries like Australia, so I lived in Australia for a long time. The way that problem was a big problem in Australia, because you got 27 million people living, most of them live in 6 big cities. Okay, so no problem for them, because that's, the geographical distances aren't too bad. But what about the country areas? You're not going to get fiber out to a little country town. You know what I mean? So the problem was that you had this big disparity, right? You had some people who had good access, and you had some people who had bad access. And so that's a problem that was a political problem for, like in Australia, is a political problem. Like people would go to the election and would vote on, who's going to give me better broadband. And so each of the political parties would have a point on that. Of course, very expensive. Yeah, anyways. So dial-up, we mentioned ISDN, old stuff, digital subscriber line. And yeah, digital subscriber line is where we kind of are, not really using dial-up anymore to connect, that even for individual users to connect to the internet, but certainly not as a WAN technology. Now I'm trying to think of it as a WAN technology. When would you use this? Maybe back in the 1980s, when somebody was just doing some kind of at the end of the day, do some kind of a little data upload. It would have to be small. Huh? Then they might have used a dial-up, once a day, dial-up, a bunch of stuff goes across, then stop. But you wouldn't want to be doing that all day long, that's for sure. Dial-up and ISDN are kind of old. Nobody's kind of using them, but they got us going. So I mentioned the central office a minute ago. So the house represents your individual user. You might be, we're supposed to be talking about WAN technologies, but this looks like we're actually talking about sort of individuals sort of getting onto the internet, right? Actually, the technologies are kind of similar. And so, so imagine this as your office. It could be a customer home, but it could be your office. And so you have this is what I was talking about, the last mile. Last mile is out there from the the central office, this remote switching facility, your little exchange in your local area. This thing here, right? Is that fiber or is it copper? And if it was copper, changing it into fiber was kind of expensive. Digital subscriber line is what operates over the public switch network. So how this is going to have to work is we're going to use our protocols. It's not just about the actual connection. And so we're going to use packet switching, that type of thing. Yeah, competes with cable broadband and T1 services, requires repeaters for longer distances. Yeah. Advanced modulation techniques. So when we talk about the advanced modulation techniques, what we're meaning is to get the required amount of bandwidth from it, we're going to tweak the actual sort of the protocols that are being used with the packets, that type of thing. So we sort of get to the limit of the way the infrastructure will work with our communications, and so we go back and we look at the protocols and tweak them a bit. And so that's what we mean here. Okay, so we can do something with it. We can, even though we're sending the same things over the line, we can tweak the amplitude, we can tweak the frequencies, and so we can get more data for the same amount of stuff we're sending through. So what do we got? We got XDSL, which means any kind of DSL. We've got ADSL, asymmetric. So that's going to be fast, but as it says that, as you get the idea from the asymmetric, it's going to have a different download speed than upload speed, faster download than upload. Good for video conferencing, web surfing. So that's us mostly. But in a business environment, yeah, very high bit DSL. So this is very high bit. Obviously, that's more attractive than sort of vanilla DSL. So also more expensive. And as symmetric DSL, again, going to be expensive because you're having a high upload speed as well as your download speed. Okay, so there's some equipment that's sort of used there. So this is a multiplexer, the Dsl multiplexer there, access multiplexer. Multiplex means that it's a computer that is able to take a bunch of different signals and combine them together in a way that they can be uncombined later. So you have a multiplexer, demultiplexer, so that you can use a single line to take a lot of different communications. So that's what's happening there. We got the single line out from the internet. We can put that through a splitter, all right, and so that we can give it to many different people from one sort of connection. Okay. So TCP, I'm sure you're sort of familiar with that. ADSL sort of relies on that using the TCP. That's at your layer 4 in your OSI. DSL modem. The splitter was in that diagram up there. Notice that's also splitting at the customer premises. The splitter is splitting our internet traffic from our phone traffic. So able to recognize the different types of packets coming through. And you know, that's possible to do, right? And telephone companies do that. They'll recognize when you're trying to use a voice over IP and maybe block it. Ever had that happen? Yeah, I have. All right, so kind of, how are we going? I was going to go up to at least, what number is that? What, 18? Oh yeah, we better go a few more. Yeah, so there's not much to say about that. The ADSL connection is using a modem. Yeah. And it modulates it, can go over untwisted, unshielded twisted pair wires. So you don't need too much infrastructure for that. We can use our copper, but it does need a multiplexer, which is going to be in our ISP is going to provide that. Broadband, yeah. I think here we're going to talk about T1, T2, T3, is it? Oh. Talking about, okay, cable companies. Oh, cable. Yeah, sorry. So yeah, like cable TV, like they had in the United States. So that's your coaxial wires. And so that's going to be a wire directly into people's houses and through their houses. I don't think anybody's using that here now. Data over cable service, asymmetric speeds. That was a big deal sort of 20 years ago. And yeah, so good for web surfing, etc. Now here's our SONET. I think this is our SONET. Pretty sure it is. Oh no, this is hybrid fiber coaxial. So what we've got is in the I saw the fiber there, and I was thinking SONET, but what we've got here is we've got fiber in the backbone, and out here we've got cable coming to individual houses. So that's why it's hybrid fiber coaxial. So yeah, if we didn't have last mile as fiber like we've got in Cutter, that might be a reasonable solution. But we do have, so there's a cable modem, and it is able to, as it says, modem, modulate, demodulate, provide a dedicated connection. We're not using those. Metro Ethernet Forum. Different organizations sort of make this possible. Traffic for LAN and WAN, so that's going to be over greater distances than your standard local area network. Ethernet best transport. Yeah, okay, so I'm just reading slides at the moment. I'm getting tired of this. All right, so our CET connections. So what do we got? A bunch of switches that are separating two different sort of little networks there. This stuff is this is all WAN technology. So these switches that we're looking at there must be in the ISP, I guess. So yeah, Metro Ethernet, that would be for your metropolitan, as it says. So for a metropolitan network, switches throughout the city. Oh, so our T carrier. What this is relying on sort of packet switching. So what we're doing is we're sort of bundling up a certain amount of bandwidth, and we're selling that at a monthly basis. And it comes in T1, T3, etc. And it's just you buy a certain amount of bandwidth. So you're just using the carrier's network and paying a price for a service, I guess you could say. So it's been around for a while. Can work on fiber, can work on wireless, can work on copper. It's just their network. It doesn't matter to you what you're getting, but they're sort of promising you a certain amount of bandwidth at a certain price. And so that's how they sell it to you. They sell it to you. They'll sell you a T1, which is a certain bandwidth, or they'll sell you a T3, which is like 28 times more bandwidth. And this just talks about what they do to make that possible, because it's just going over their network. They have to somehow split your connection from other people's connections. So they use the multiplexing idea. And so they have equipment to do that time division multiplexing. T3 would obviously be more expensive than T1 because it's 28 times faster. Now we got this other one, which is maybe you want to have a lot of flexibility. You don't want to have to use all of that T1. You can have a fractional T1 so that when you're not using so much, you don't get paid so much. You don't have to pay so much. You only have to pay according to the little bit that you use. All right, so T1 supports voice and other data. ISDN PRI is a sort of a added value ISDN, but again, so ISDN can work with T1. ISDN is using our protocols. SIP, Session Internet Protocol Trunk, using voice over IP. Now, I mentioned earlier in the lecture about this smart jack as a sort of a connection between us. Do you notice that we've just got the Z line there representing the public switch network between there, and then we're going to have these other devices. This is still owned by the public switch network, but they're going to install a smart jack and a CSU DSU for us, and that just represents their network in between, which we don't really know. So just going back there, yeah, all right. So we do actually have the customer responsibility and the telco responsibility separated there. So the CSU DSU, that's what we call our DTE, that's our customer responsibility. The telecom network, we don't care what they do, but they got this smart jack, which is going to be at our DMARC, right? Our DMARC is the demarcation between the two. I think I just about got to halfway, so I'll just finish after the T carriers. And so the smart jack is a terminator. That's going to give us our point-to-point connection if we had that. The CSU DSU, that's our DTE, our customer managed equipment. And so the CSU provides a termination, DSU converts it to the frames that can be passed on the network. Multiplexer is used by the telephone network to put a bunch of signals together over the network and then to separate them out at the other end. So that's something that they sort of consider. And there's a diagram of T1 connection to a LAN. So the T1 connection is coming from our service provider through the smart jack. All the stuff that's in yellow and coming off of it, that's the customer's responsibility there. Now, so why has the customer got a telephone switch? This is like a private network, private, so they call it like PABX, you know what I mean? So you can bring in, well, that's how the college works. We have a PABX system. You have one telephone number that everybody from outside can call. You know, that's a 44495 number. And then everybody in here has a number which is based on that. Now those 4495 numbers, they're only used by the college. There's nobody outside the college that uses that 4495's numbers. That's because that's the number that accesses our private telephone network. So our private telephone network is actually part of the thing that we're getting from Aredo. And so it's part of the WAN. We actually receive it as if it was an internet connection. Well, it is, you know, it's voice over IP. And so the signal that's coming in is going to be sort of split there, and the switch is going to be used to provide us with our private network inside here. But as far as the telephone company is concerned, you know, those numbers aren't their numbers. Those are our numbers. You know, our IT people organize those numbers. They assign those numbers. They can change those numbers. It's nothing to do with Aredo. Aredo just provides us with this. And then all of this is ours. Okay, so I said I'd go like halfway because I think this is a big lecture. I don't want to go too much, and I'm also getting tired of talking about it. So I'm going to stop there. And